Welcome to this section. Our task or problem we are to solve is to be able to get, say, these images and correctly classify them. That's to say whether they belong to one of the 200 classes in the tiny image dataset. And unlike the other tasks we have had to work with throughout this course, we now have many more classes we're working with. And the dataset, which is that of Tiny Imagenet, is made available to us by lecturers of Stanford University, which you can download via this link. Then after downloading and extracting, you should have this folder, which is Tiny Imagenet 200, to say we have 200 classes. This again is made of 3 folders: the train set, the validation set, and then the test set. We shall see what the use of these 2 files are shortly. For the train set, we have 200 different items. Now, this will say that each of the 200 classes are represented in this data set. And then if you get into open one, you have here these items, and then open this image folder, you have 500 items. So actually, for each of these different classes, we have 500 representatives. And then if you go back, let's take the very first one. If you take this one, this is given by N0114. Let's take note of this. So we could copy this, go a little bit back. We have these words. Now if we take a look at this dot text, and then we scroll down, we have about like 82,111 lines. So this is the number of lines we have in this file. Scroll up, and then if we try to look for this folder in this words.txt file, you should arrive just here. We have this. If you notice, this actually the folder we just saw, and we are told here that it's actually goldfish or Carassius auratus. Most probably this is his scientific name. So here we have goldfish. Now let's come back to training set images, and if we take a look at these images, we see clearly that we have to do with a goldfish right here. So keep on moving, and we'll see the different goldfishes in our data set. So that's it. See that our training set is made of 500 times 200 items, so that's made of 100,000 items. Our validation set is made of 10,000 items, and then our test set made of 10,000 items too. And also checking back at these images, we'll notice that we have to do with 64 by 64 images. Let's take this. Here we have 64 by 64. You see that's actually the same dimensions. Now this hasn't changed right here, so let's do something like this, 64 by 64. Anyway, all these images are 64 by 64. That's an important point to note. But what's interesting with these images is that we have the same class in different kind of conditions, and that's actually the whole point of this tiny image data set. Now before moving on, let's take a look at the Imagenet data set itself. So it's called Tiny Imagenet because it's part of this large Imagenet. Now what's this Imagenet about? As you can see here, it's an ongoing research effort to provide researchers around the world an easily accessible image database. So as a researcher working with images, you don't have to necessarily go and create your own database whenever you want to do or whatever work. So you just have to come to this database made of 14,197,122 images with 21,841 scene sets indexed. So like cats, search cats, should have the results. So let's say cat. All right, so we have, for example, cat, and now this cat is in different categories. So in this scene set, we have the tiger cat, the Lesenda panda, the red panda, and there's different pandas than the Egyptian cat. And what is to be noticed here is we don't only classify that the image we're seeing is that of a cat, but we go up to saying what type of cat is it. And Imagenet is an image dataset organized according to the WordNet hierarchy. Now, each meaningful concept in WordNet, possibly described by multiple words or word phrases, is called a synonym set or scene set. So that's just what we just saw, where we had a scene set by name tiger or cat. And there are more than 100,000 scene sets in WordNet, where majority are nouns. In Imagenet, we aim to provide the authors of this Imagenet aim to provide on average 1,000 images to illustrate each scene set. Images of each concept are quality controlled and human annotated. So as you can see, the why for the Imagenet is inspired by a growing sentiment in the image and vision research field, the need for more data. That's very, very important, because without data, your algorithms can't do very much. So ever since the birth of the digital era and the availability of web-scale data exchanges, researchers in this field have been working hard to design more and more sophisticated algorithms to index, retrieve, organize, and annotate multimedia data. But good research needs good resource. So to tackle this problem in large scale, it will be tremendously helpful for researchers if there exists a large-scale image database, and that happens to be Imagenet. But in this course, we shall work with tiny Imagenet. And obviously, Imagenet has always been a very useful resource for everybody, researchers, academia, and even in industry, as models trained on Imagenet are used to fine-tune other models trained on other datasets which are maybe useful in a particular domain. Now, does Imagenet own the images? No, Imagenet does not own the copyright of the images. Imagenet only provides thumbnails and URLs for these images. So you can be provided access through your site, so you could check for details to have this. Nonetheless, we're working with tiny Imagenet 200 and not the Imagenet itself. So that's why instead of this 14 million images, we have just 100,000 images. And another factor which has led to the popularity of Imagenet is the Imagenet Large Scale Visual Recognition Challenge. So that's the ILSVRC, which entails developing algorithms which can classify images over 1,000 classes. And interesting enough, the ILSVRC challenge has been won for the past years, that's from 2012, by researchers who used a particular type of neural networks, and that happens to be convolutional neural networks. And the challenge that year was won by Alex Krzyzewski with the AlexNet convolutional neural network. By 2015, ConvNets had already beaten humans at classifying these images. So we have the machine error, which was less than the human error, which is at 5.1. And the way this human error was derived was by Andrzej Karpathy, a researcher at Stanford University, who went through the millions of images, classified these images, and then compared his results with the ground truth. And that's how it led to this human error of 5.1%. Although this percentage may increase or slightly reduce depending on how much time the person takes to classify those images. Today, the most popular neural network architecture when it comes to image data is the convolutional neural network. And although formed by stacking up several neurons in different layers, they are quite different from the kind of deep neural networks we had seen previously in this course. And in the next section, we shall go in depth to understand how convolutional neural networks are modeled.